Hi everyone and welcome to the video on extreme values. So this is a topic that comes up very much in mathematics, has a lot of applications, and this is going to be your first introduction to this topic. So mostly we're going to cover definitions, and all you're really going to be expected to do in this class is to either read it off a graph if I give it to you, or later on when we start doing calculator labs you should be able to find extreme values with your assistance on your calculator. So let's talk first about local minimums. So a function has a local minimum at some location x equals c. So again, you want to think about the person walking on the hill, and the x coordinates give you locations. And apparently I can't spell locations today. And again, y is going to give you height relative to something. So you have a local minimum at x equals c if this coordinate is less than or equal to x for some interval. So let's look at what that means. That means this person is walking along. This person is going to get over the top of this hill. It's going to keep walking down the hill, and eventually this person is going to end up at some low point at the hill, and we're going to call that location C. So that's where this part comes in. That is the location. And then what the rest of this means is that if we look at the height here, so let's get this person off the ground here, so the person is right here. Now if we look at this height here, and then compare it to some nearby heights, so this is your interval AB, we notice that this is the lowest point in that region. And that's basically what a local minimum is. If you look at a graph, it is the lowest point in a given region. So notice that this graph only has one local min, but you can actually have any number of local mins. So you can have any number of local mins. And that's really all there is to it. So basically what you'll be given is a graph, and you'll just be able, you need to tell me at what x coordinate the local min occurs, so in the case x equals c, and then what the height is, so what is the y coordinate. So you just need to be able to tell me x comma f of c. You need to be able to tell me what those two values are if I ask for it. So let's look at local maximum. The definition is very similar. But this time, as we're thinking about this person walking on the graph, we want to know when he or she gets to the top of a hill. So in this case, when we're at this point. So this is now what we're calling C. So again, we have some location x equals c, but notice that this time the inequality is reversed for all x in some interval. So now I can pick some interval AB near where c is in location, and this is going to be my interval AB from the definition, and notice that this is the highest point for any of these locations, and that's what it means to be a local maximum. And so again, what I'm looking for you right now is that if I ask you where a local maximum is, you should be able to tell me the x and y coordinate of the local max. Some questions will ask for location, while some questions will ask for value. I just want you to be able to identify the points where the local maxes and mins are located at. So, this is C, F of C here in this case. Alright, so that's local min and local max, and then there's a related concept called global min and global max, or also known as absolute min and absolute max. And so the idea here of this type of graph is very simple. There is an absolute lowest point. So with a function like this, for example, before I draw, this continues on forever in this direction, continues on forever in this direction. So if this person keeps walking in this direction, this person eventually will just keep climbing higher and higher forever and ever. And if the person goes this way, this person will go further and further down forever and ever and ever. With absolute mins and global mins, there is a stopping, or there is a highest point. There's not necessarily a stopping point, but there is a highest point. So sometimes absolute minimums can occur at endpoints. So here's the absolute min, that it's the lowest point on the graph. So if the person walks this way, they'll eventually stop here, and that is as low in height as they can go. But if they walk this way, they can go on forever and ever in height. But as you've seen in the previous example, we don't have to have a global min. There's no global min here. Global mins do not have to be at the endpoints. So let's draw an easy example of this is the parabola. Alright, wrong direction. It shows, so the local min is right here, and that's the lowest point, but it still goes forever in direction in both places. So you can have, sorry, it is a local min, but it's also an absolute min as well. So you can have absolute mins in the middle of the graph, you can have them at the endpoints of a graph. It doesn't matter if one side goes to infinity, both sides go to infinity. It can occur with all types of different graphs, and when you get to calculus, you'll find a criteria to be able to figure out when you can always guarantee you have a local or an absolute max and min, and where to find them. And similar comments can be said about absolute maximum. So again, absolute maximum, there's just some literal highest point. So if the person is walking on the graph, you know, this person will get up to here, stand on top of the dot, and oops, that made the dot disappear. Get up here to the top here, and that's as high as that person could go. Again, you doesn't have to be at the end point. We can look at a parabola opening downwards, and the highest point is right here. So here's the person standing at the highest point. One thing to note, you can have both absolute min and absolute max. So let's see. So your absolute max would be right here, which is also a local max. But you have a local min as well, way down here. So, and then we have local maxes here, and a local min here. So you can have all sorts of combinations of local mins and maxes, absolute mins and maxes, and they may even coincide with one another. But for now, we're just saying that, you know, where are the peaks, where are the valleys, and you tell me their coordinates. That's all we're going to do. So thank you for watching this, and we'll see.